Guys, first and foremost, take in what you can from this. We're gonna make these short 20-minute clips, okay? Every Monday, and we get as much information to you guys in that 20 minutes as we possibly can. This is for you guys, okay?
Quickly. All right. Rob talks every week about a ceiling. You know, this is, what is your personal ceiling? This is how you start, okay? The important thing I want you guys to get out of this is I want you to understand why you're doing what you're doing rather than just doing what you're told, okay? You're not going to get anywhere if you don't understand. If you don't understand things, you're just creating tasks, okay? So what we're trying to do here is start at the bottom and work up. Now, some of you, this is all repetition. Some of you know this stuff. If you do, help the guys who don't, okay? But we're gonna start from the very basic, and we're gonna go up from there, okay? So, let's start with basics, okay? In front of everybody is a tape measure, okay? This tape measure is a little bit different than most, and if you look at a couple of them that here, you'll see because this one actually has fractions of an inch laid out on it, okay? If you look at any other one, as a rule, it will not, okay? So this is a good learning tool for you. Take this tape measure home with you. The most important tools in your toolbox are going to be this pencil and this tape measure. Anybody who's been doing this a while will tell you these are the two most important tools. Without these, you can't do anything. So this tape measure has to be something that you totally understand. It's going to help you with layout. It's going to help you do everything. And when you start getting into things like setting benchmarks, getting square angles, getting things done, you're not going to do it without totally understanding this tape measure, okay? So let's start with a couple of things. One, you see the tang at the end, okay? This moves. It's not broken, okay? It's supposed to move. It moves the distance as thick as this is. What that means is if you hook it, it moves out. If you push it this way, it moves in. If it were frozen, you would get a different measurement when you hooked it like this than if you pushed it like that. So this is supposed to move, okay? If you ever get a tape measure that doesn't move, put it back on the shelf, okay? There's two scales that we generally work in. There's architectural, which is what you see here, and there's engineering scale, which is broken up into tenths and fractions of a foot rather than inches, okay? We're not going to go into our engineering scale right now. It's only going to confuse you, okay? But for matters of what we're doing now, we're sticking with this. Everybody got that? Okay. When you look at this tape measure, you'll see a couple of things. It's broken up into eighths of an inch. Does everybody see that? Okay? What that means is you take the inch, divide it into 8 pieces, that's it. There's different size lines on a tape measure. Okay? Some tape measures are broken up to eighths of an inch. Some tape measures are broken up into 16ths of an inch. Make sure you understand what you're looking at. I had a guy when I worked in the Carpenters Union. He was a carpenter for 40 years, and we used to tell him, you measure it, tell me what the dimension is, and I'll cut it. And he would call me and go, 43 and 3 little lines, because he didn't know how to read a tape measure. The guy had been doing it for 50 years. He didn't know how to read a tape measure, okay? Understanding this tape measure is probably the most important thing you'll learn, okay? The reason I'm pushing now so you understand the fractions, because when we get into scale, understanding the fractions will be very important, okay? So open a tape measure to a foot. Everybody should have one. If you don't, let me know. I've got extras here, okay? Do you see the fractions on this? Printed on this tape measure? If you look at the other side of the tape measure, there are no fractions, okay? Because on a standard tape measure like you see here, you're really not going to see that. This is an excellent learning tool, and you should keep it so you understand, but this is not what you're generally going to see on a job site, okay? This tape measure is broken up into 16ths of an inch, okay? So if you look at the 1/8 of an inch mark, you'll see this like 4 different length marks on this. The smallest one being a 16th, the next biggest being an 1/8, and you can all see that on this tape measure. The next one being a 1/4, and then it goes back down to 3/8 because you'll count 8s going across. Does everybody see that? Does anybody not get that? There's no shame here. If you don't understand, tell me you don't understand. Okay? Some of you, like I said, this is repetitive. To some of you, this is new. Okay?
Guys, I'll be perfectly honest. When I started at Dale Construction, if you asked me where 5/8 was on that measuring tape, I don't necessarily know I could show you. I could probably stop this right now and have each and every one of you show me 3/8, 5/8, 7/8 on the tape, and I bet you I could jam a couple of you up. It's silly, but stop and ask the questions. If you guys don't know, this is the venue to do that at. It's really small things that are going to make you grow individually so that we're better as a team. Go ahead, Joe.
Okay. So this isn't something you have to absolutely absorb right now. Take this with you, study it, you'll understand. Okay? There's a few things the way a tape measure is set up. One, it's set up 1 to 12 after inches. And then once you get to the 1 foot mark, if you all look, it'll start again. One side of it will say 13, 14, 15, and the numbers will continue. The other side will start at the 1 foot mark, the 2 foot mark. There's a reason for that. When you look at a plan, it doesn't always say 122 inches. Sometimes it says 10 foot 2. It doesn't always say 24 inches or 2 feet. It'll say 2 foot 3. This allows you to open up to 2 foot and then go to 3. You follow what I'm saying? So instead of saying on a plan, it's 26 inches, it might say 2 foot 2. So you can go to the 2 foot mark and you can look at 2 foot 2. You can go to the 3 foot mark and look at that. So if you have a plan that has inches or feet and inches, the tape measure allows you to do both. You guys got that? Anybody confused by that? Okay. There's a few notations on a tape measure which you will use. If everybody looks at the 16-inch mark, every tape measure is a little different, but usually it's in red. Usually there's an arrow of some sort. On this tape measure right here, it happens to be red. If you open up to the 32-inch mark, you'll see it's red again. The reason for that is most things that are framed in 16-inch intervals. So if you're laying out studs, for example, on a 16-inch wall, you can pull the tape measure across, and you'll see the red marks every place you have a stud, rather than going 16, 32, 48, etc. You can actually just look at the tape measure and get it. As you keep using this, it will get a little more clear to you every time, okay? But understanding your fractions, understanding how this is laid out is going to be the most important thing you guys can figure out going forward. If you can understand this, you can understand where we're going after this, okay? Is anybody confused by this at all or have any questions? You all got this? Sure.
Joe, every once in a while, and pick somebody out to answer. Make sure they actually do.
Okay.
Guys, it's okay to ask questions. It's okay to not be the smartest person in the room. I will promise you, in any meeting I sit in, I am not the smartest person in the room. If you don't get it, stop them. That's why we're doing this. There's no way that everybody knows everything this Joe is talking about.
Okay.
And don't be the guy who just doesn't want to ask the question because you feel like this is elementary stuff you should know.
Okay. I have sat down with people over the last couple of weeks and done this. And for the most part, people don't totally get it. And it's easy for me to sit down one at a time and say, this is 1/8 of an inch. It's hard to sit down in a room with 25 people and say, this is 1/8 of an inch, and everybody go, okay. So if you don't get it, it's okay. Okay? You learn. If you don't have it, come see me afterwards. Talk to Devin, talk to Marion. Oh, don't talk to Marion. talk to Dan. You know, we can get through this. Somebody find me 3 foot 2 on this tape measure. Everybody got it? Okay. So this is the first part of understanding how things work. Like I said, we're not going into engineering scale right now. Engineering scale will throw you off. Okay, so take the tape measures home with you, okay? You should have a tape measure and a pencil on you at all times, okay? I've had teachers and I've had foremen that used to beat me up if I didn't have a tape measure hanging off my belt. Even as a laborer, as a worker, as a carpenter, everybody should have a tape measure hanging off their belt, okay? Now, just like it's important to learn this, I want someone to understand some basic things, okay? Everything you do, you learn from. Okay? If we give you a task in the field, I want you to dig down 18 inches and put a pipe. I want you to ask why. In your mind, I want you to say, why am I doing this? Okay? Because if you don't understand why you're doing something, you're not learning from it. Okay? If I give you 10 tasks to do, there's a reason those 10 things are being done. If you don't understand why those things are being done, the next time you're just digging a hole. You're just drilling a hole. You know, if you don't understand why, you're not learning anything from it. Anybody here who's been doing this for a while can tell you they've learned two ways. One, by doing it right, and two, by doing it wrong. Okay? They've also learned by watching other people and how it works out. Anybody who's been doing this a while, who works and watches a framer, learns things every time they see a framing done. Every time they see a guy run a piece of pipe, they learn something. I want you guys not to just blatantly do tasks in the future. I want you to comprehend why you're doing those tasks. Okay? You will build a vast amount of knowledge by watching people who have a vast amount of knowledge. Okay? You watch people do something wrong, you know it, right? You see something go wrong, you know it. Whether you understand it or not, you've learned by watching that guy do it wrong. You will never do that. Okay? In the future, you'll do something and you'll say, someone will come to you and say, how'd you figure that out? Because you've done it enough times or you've watched other people do it enough times to learn from what they've done right and from what they've done wrong. The reason we're showing you a tape measure is so you understand this, not so you're just picking off 1.5 feet. I want you to understand how it's 1.5 feet. How did you get it? What makes it up? Okay? As you go through your day, everything you see on a job site, ask. There's a critical path involved. If you were changing the brakes on your tire, you wouldn't say, I'm going to change the brakes, but I'm not going to take the tire off. You would say, I got to take the tire off first, right? Everything in construction is a critical path. This happens, then this, then this, then this. If you learn that critical path in everything you do, and you start thinking in terms of a critical path, you will figure out how those tasks work. What has to be done first? How do I accomplish it? Eventually, you'll get to the point where you practically build everything in your head. But everything along the line, you have to make sure you understand. You can't just take for granted, I got to drill a hole at 18 inches. You have to understand why. Everybody got that? Okay. Take this out. Everybody got one? Okay. This is an architect scale. There are two scales that we work with in construction generally. We work with an architectural and an engineering scale. Like I said, we're not going to go into engineering scales right now because I think it would confuse you. Okay? But the architectural scale is something you use every day. It's based on this tape measure. Okay? So for right now, we're going to go to a simple one. 1/8 of an inch scale you've seen on this. We're going to go to 1/8 of an inch on this. Okay? So if you look at this, as you turn, you'll see there are different numbers. 1/8 inch, 3/8, 1/2 inch, 1/4 inch. Do you see that? Okay? These are all scales based on percentage of an inch and how they relate to real time. I'll explain that, okay? If I wanted to measure this table, let's say it was 4 feet long, right? And I wanted to do a drawing. If every drawing was in real time, my drawing would be 4 feet long, right? If I had a blueprint for a house, it would be 100 feet long, right? In order to do a drawing so that it fits on the paper and as you understand it and everything jives, it's broken down to scale. So when I say real time, I mean in life, okay? So where you see a thing on here that says 1/8 inch, what that means is for every 1/8 of an inch on here, just like for every 1/8 of an inch on here, it relates to 1 foot in real time, okay? So if I had an inch on here, that's 8/8, right? That would equate to 8 feet in real time. If I had 4 feet, if I had 1/2 inch on here, that's 4/8. That would account to 4 feet in real time. So what the scale does is it allows you to take a line from the tape measure and relate it to real time. So I'll give you an example now. Let's say I'm doing a drawing and I have to measure from point A to point B. And Marion will tell you you never scale a drawing, but for matters of here, let's do this, okay? If I'm measuring a room on a set of drawings and it's an 1/8 inch scale, I go to the tier and you'll see every 1/8 of an inch on this drawing is not listed as an 1/8 of an inch, it's a number. And if you count the 8s across and you get to 4 lines, it says 4. When you get to 8 lines, it says 8. The reason they do this is rather than saying 1/8 of an inch, 10/8, it's literally taking every 1/8 of an inch and counting it as a single foot. You guys understand that? So if I'm on a drawing and I put it from point A to point B, and it's, rather than saying, all right, it's 4 inches times 8, it's 32 feet. I can count on here, start it on 0, and I can use the numbers across to count how many feet it is. You guys understand that? It's a little bit harder for you if you're not grasping it. Okay. This scale is broken up into what you will see on almost every drawing you have. Common drawings are like 1/8 inch, 1/4 inch, okay, 1/2 inch, 3/8. The bigger the scale, the bigger the drawing. Okay. Some will say as noted, where if you see a blow up, if it's as noted, it's either what it says because the numbers will be written in rather than using a scale, or some of them will say full scale, which means an inch equals an inch. Okay?
Where is that normally notated on the plans?
Right, if it's either on the title block on the corner, or it's on right underneath the drawing. Okay? Be careful when you scale things, because sometimes drawings are not printed in full size. If a drawing is printed half the size, like let's say you get a drawing on an 11 by 17, okay, and it's really supposed to be printed on a full drawing, but for matters of what we're using it for, it's on an 11 by 17. So we can reference it. You can't use the scale, because an 1/8 inch on that scale is not what it's intended to be, okay? So when you look at this, you'll see 1/8 inch, you'll see 1/4 inch, you'll see 3/8. It's important that you understand on here which scale you're looking at, okay? If you look at a drawing, usually there's a title block on a drawing, okay? It usually says, and you've all seen this, it says the job name, the architect's name, or the engineer who's ever drawing it. It'll say the date of the drawing. It'll say revision date of the drawing. But on the bottom, it'll say scale. And it'll either say 1/8 inch, 1/4 inch, whatever it is, or as noted. Okay? It's important that you're looking at the right drawing, the right scale on the drawing. Okay? From that, you can do almost anything. If you go to a detail, where there's a blow up of, say, a wall section, it may be 1 inch scale, or it may be full scale. You always use the biggest scale available. If you have 3 drawings for the same thing, and one of them is in like 3/4 inch scale, and one of them is an 1/8 inch scale, you always use the biggest blow up, the biggest scale. Okay? So if you look at this, this directly relates to the tape measure. If you look at 1/8 inch scale and you run the tape across it, right, you will see that the 1/8s on here line up to the single dimensions on here. Everybody see that? If you go to the 1/8 inch mark, okay? So you could do 2 things. If you want to scale the drawing, you could either use a tape measure and figure out 1/8, take the number, if it's 1/4 inch, take the number of inches, multiply it by 4, all these things. This is easier, okay? This is easier, it's more accurate, and it helps you. Whenever you do something, just a quick tip, whenever you measure something on here, try never to line it up with the tang. If I'm measuring from here to here, don't line it up with the tang, because the tang is not always a good dimension. Always start at like the 1 foot mark, because you can clearly see the 1 foot and where it goes. If you start it with the tang, you're never really sure, because remember, the tang moves, right?
I like to do it from the 10, so it's
Yeah.
just like a...
I always do it from the 1 foot mark, because then you're starting again with 1, 2, 3, 4, 5. Okay, you can do it from anywhere. I find starting at this actually gives you a clear start and an easy way to read it because you're starting with single dimensions again.
You're gonna hear a term in the field, burn a foot,
Yeah,
critical, because if you're holding the end of the tape and I'm doing the critical measuring and you've got that off, our layout can be off. So,
okay. So really what I want to get everybody to understand today is understanding the tape measure and how it works. Take this home with you, okay? Everybody who doesn't have one, we have extras, okay? Take this home. When you're on the job, make sure you have it on your belt, okay? Look at this. Look at the fractions and how they relate to the side that doesn't have fractions on it. Now, not every tape you get is going to be the same. Some of them are going to have 16ths. Some of them are going to have 30 seconds, which are really hard to read. Okay? Some of them are only going to be eighths. When you buy a tape, make sure you understand what you're looking at. All right? If you ever see a long tape, I'm going to roll like if we use when you're doing landscaping. One side will look like this. The other side will say 0 to 10. That's an engineering. We're not getting into that. I don't want to confuse you with that right now. Okay? So what I'm trying to teach everybody right now is this. Understand the tape measure. Once you get the tape measure, understand how it relates to scale. Okay? This is going to be used in everything you do. When we set a benchmark up, when you do a XY axis on the floor, which you guys, some of you have no idea what I'm talking about at this point, but you will.
What's a benchmark?
You're a wise ass.
no, seriously.
All right, let's go through this, okay? When you're doing layout, which is something we were going to go through in a couple of weeks, but we'll go through it now. A benchmark is a line that you put, horizontal line that you put all the way around the job. That's the reference point for everything that's done at the job. Usually what I do is I take the high point in the floor, I come up 5 foot, and I put a mark all the way around the floor with a laser. What that does is it allows everyone to work off the same dimension. If you're working and you're putting the floor in and you know the floor is 2 inches up, you can take the benchmark, come down, get your point, and with a laser keep that steady all the way around. It lets the framers hold the heights right for the doors. It gets the heights right for the windows. It lets everybody on a job work off the same mark. The guys who are running electrical and they're going to run outlets and they're going to run switches, they all have to be a set amount off the floor. If you have a benchmark and everybody's going by that mark, everybody has the same height. For example, if you have a 5 foot benchmark and all the outlets are 3.5 foot up, or all the switches are 3.5 foot up, you go 1.5 foot down from that benchmark, that's the center of your switch. You're never going to have a place where a guy measured off the floor because the floor is not level. Okay? So a benchmark is just a critical line that everybody uses on the job. Plumbers, electricians, carpenters, everybody, to hold that. An XY axis is a line you put on the floor. It's a right angle, squared off of the walls. So everybody laying out walls, floors, whatever, is off that as set dimension. That way you know everybody's parallel, everybody's square. You don't wind up with walls that are like this because everybody's measuring off that square line on the floor. Okay?
And it's important, guys, to understand that that's not just a random line that Joe or I or Carl or someone picks. That's actually a line that's determined by the surveyors and established somewhere on the site wall. It's taken from a control elevation point out on the road somewhere. And we follow that through the entire project from grade all the way into interior framing. So it's not just a random thing. So it's very important.
And that XY axis on the floor carries from floor to floor. Okay, it's not different on every floor. You pick the same point on every floor. So when you're working on a stairway or you're working on an elevator or you're working on things that carry from floor to floor, that XY axis is going to be equal. So if you know your elevator, just for a number, is 5 feet off of the wall here, when you go upstairs, it's 5 feet off of the wall there. Okay? All these things, everything is based on this. Okay? So take this home, look at it. Make sure you understand what all these fractions mean. I can't tell you how many people, if I said to them, show me 6 1/4 inches. They wouldn't be able to do it. It's not, for the most part, it's not that they're dumb, it's that they've never been exposed to it. The point here is we're exposing you to it. We're giving you a tape measure, we're giving you a line that actually is like a tutorial on the tape measure. Use it, learn from it, okay? Practice. But make sure you carry this around with you everywhere you go. Does everybody have one? Does anybody need one? Okay, everybody except for you guys who have them already. Take one of these, take one of these. Go home, take out a plan, take out a newspaper and go from point to point and get a footage. Make sure you understand how it is. If you need help, Drew, Devin, Marion, Dan, any of us can help you, okay?
Let's find a sheet, one of our sheets of something, whether it's a guest house or garage or something. Next week, let's have a 24 by 36 printed, we'll hand them out. And they can go in, we'll actually blank out the measurements, and you guys can go in and add all the measurements and figure it all out, and bring them back for that following week.
Good idea.
Because these things really give you empowerment on the job site when it shows you're holding all the other trades and the guys to task. So when you roll up with a tape measure and you start measuring stuff that these guys are doing, they realize that you're paying attention and you're checking and double checking what's going on. So it's a very important tool.
The other thing is, just like we're saying here, make sure you understand this. There's a lot of guys on the job that don't. So don't take for granted, you know, a lot of people, what they do. When I was in school, I went to carpenter school in the Union, and you used to watch guys when they give them a drawing and everybody would build, and the first guy would make a mistake and you'd watch the next 5 guys after make the same mistake because everybody's watching the guy do it wrong, okay? If you understand how this works, you're not going to make the mistake by following somebody else's mistake, okay? Do it, double check it. Remember an old line, measure twice, cut once? Same thought, okay? Make sure you understand this, and don't take for granted that everybody else knows more than you, because they don't, okay?
Guys, when I was a green project manager 17 years ago, there was 2 things that I better have when I was walking around that site with my predecessor. I better have a notepad with a pencil, and I better have a tape on me. And if I didn't, it was a bad day. So when we're out in the field, when I'm out in the field, when you're out with your executive project managers, you guys should always have a tape on you, and you should always have something to write and take notes with, whether that's your iPad or whatever that is. But you need that with you at all times, especially when you're walking around with your management and myself.
I know this sounds basic, but this is the fundamental you have to get right. This is what you have to understand, not just see a picture of a number. The next tape you buy probably won't have it. If you look at any of these, they don't have it, okay? And they probably won't, okay? It's important that you understand. There are other things on here which we'll get to, like the stars that deal with framing for roofing and things like that. Right now, just get the fundamentals down, okay? Anybody got any questions?
This happens a lot because of how plans are drawn, so it's a question. Mr. Professor, what do we do when the plan does not have a number on it and a tradesman comes and says, I will just scale it? As a project manager, what do you want us to do as superintendents?
Give us an example.
For instance, a wall layout is going to be 12 feet 3 inches, and the architectural is only does not have that 12.3 recorded on it, where I can't figure it out. And the framer says, I'll just scale it. What are we going to do at that point?
Generally,
Are you at layout?
I'm at layout.
On the ground?
Yes.
Go ahead, Joe.
well,
might-
me personally, I love CAD. Okay, and CAD, which we'll get into later, is computer-assisted drawing, drafting. It lets me actually pick those points out and use it. Sometimes that wall relates to something else on the job. Sometimes it relates to a lineup with a window. And this goes into critical path and thinking ahead. If you're doing a layout, and let's say I'm lining up to a wall, you gotta think ahead. That wall's gonna be drywall, I'm gonna be 5/8 back from that, or 3/4 back from that. Try not to scale. Okay, scale's a great reference, but not for final
So
layout.
in layout, and I completely agree, in layout, if you're dealing with a framer in that layout phase, if it's my site, I'm gonna let them finish laying out that entire space, and I'm gonna go back and reference where that window falls, you know, where the critical pieces are that are moving around in that space. If at all possible, when we have the time and the availability, I wanna go back to the architect or designer and say, give me measurements. These are the measurements that I need. If you're just on the fly, you already got the framer there, you're already doing layout, there's nothing wrong with putting it on the floor and finding out it's wrong, right? One of the other things that's real interesting in what we do for a living is you gotta start to watch different architects.
Sometimes too, if you're looking at it, sometimes if you look out, there'll be a bigger elevation, there'll be a cut of the room on a different drawing. Or, where instead of saying this whole plan, it'll give you just that room and the details within that room. Like we said, go to the larger scale. That will give you the intent of what they're looking for. And Rob's right, most of them don't account for the 1 5/8 stud wrapping around the room and how it relates.
And some of the guys we can work with are still throwing furring strips in there. Everybody knows what a furring strip is on block? We don't do that in what we do for a living. But some of the architects that we deal with are still using that as their space off the block.
And there's nothing that says you can't lay the whole thing out and not put the track down yet. And then find your issues where you have a conflict. And then go back to the architect and say, look, your drawing says this. In reality, I have this because of this. How do you want to address it? Okay? Going back to millwork and cabinet drawings to see what the intention is for that wall. Going to all these things. It affects you more and you don't realize this yet. But if you have a dimension that says this room is 12'3" and you're laying out lighting, and your lighting has got to be centered on the room, but the room is not 12'3". Now your lines are off. Okay, so you have to go back and start with what do I really dealing with. Remember we talked about there's scale and then there's real time. There's a scale and there's a set of drawings you use to do your layout. But when you sit down, you still have to use your brain and you have to say, this is real time. How do I deal with the discrepancies in real time?
And that's more than just laying out the floor, to Joe's point. What else is in that ceiling? Is there a tray? Is there a soffit? Is there special details? Is there beams? It's not just the lighting. Where is the HVAC going? How does that lay out? Is there a fan? All of those details. How does that lay out with where the master bed goes? How does that lay out with where the window is? You gotta think through all that stuff. If you're just looking at a floor plan and you're laying out, you're not thinking through the entire process. And we'll get to that. It's gonna be months, but we'll get to that.
This is why I'm saying it's important that you understand. If you just look at the plan, like Dan said, there's a dimension that you can't make, and you're lost. But if you understand what you're looking at, and you understand how it was done, and what the intention is, if you understand it, you can go forward with it. If not, you're dead. Okay? So as you go along, make sure you understand everything you're taught and everything you're reading. If you don't, you've got hundreds of years of experience here to go ask people, I need help.
Okay, so the other thing to think about now, what you go there, is, and Dan, this isn't critical of you by any means, so don't take it this way.
Right.
If you guys know you have framers coming to lay out tomorrow, or a week, if you're doing your lookout, if you're doing your forecasting what's coming, and you know you have framers coming, you should already be in your plans. What measurements don't I have? What information don't I have? What do I need from the architects or designers to be filling in the blanks? Because if you're already ahead of that, you're not standing there with a framer trying to figure out what dimensions he's coming up with or scaling. Now that's not always going to be possible. And again, if I'm in that instance and the framer's there and they're laying out, I'm going to let them lay out and I'm going to go find the problems in that room that we've created now. But if you're thinking through the process and what you have going on, you should already have filled in all those blanks leading up to them being on site.
And once you get that layout, you got to realize that it correlates to everyone. Plumber's going to be doing core drills within those walls to bring piping through. The electrician's going to be doing core drills. If that layout isn't correct, then all those holes are in the wrong place. When we do a basement and we're going to work our way up, we usually have the carpenter come and lay the floor out for a couple of reasons. One, it makes sure all our structural columns are in the right place. It makes sure we don't have any conflict as we go up. Because if that floor layout is wrong on a lower level, it's going to telegraph to the floors above. Okay, so understanding the layouts, the rooms, the measurements, all that stuff is important. Don't just take it for granted that what's there is right. And don't just assume that everything is thought out by the architect, because I can tell you right now, it very rarely is. Okay? Any questions?
Carl, any thoughts? All right.
I just want to say the short answer is send an email to the architect. We, RWB, me, I don't want the liability of making a mistake and causing a problem, so not that we can't work through it like these guys have mentioned, but send the email out, get the information. If not, pick up the phone call. It's pretty simple.
The one thing I always say is, I never want to call the architect and say, how do you want to do this? I always want to give him a solution. You know, we measured this room out. If I do this, I get this. If I give an architect or someone outside that's not looking at what I'm looking at, a blank question, how do you want to handle this? I'm going to get a stupid answer back. So what I always like to do is measure it all out, give him, this is what it says, this is what I have, this is what I recommend we do, and this is why. How do you want to address it?
This is what it scales to, this is what it lays out to, how would you like to proceed?
Give them one
Once you're
or
at that point, that's the course of action.
give them one or two options that you see as a reasonable means, because if not, they'll come up with a third option every time. That makes no sense because they're not looking at it. Okay? There's an old saying is you never want to ask a question you don't know the answer to. Okay? If you're going to talk to an architect and engineer, go in there with a resolution to your question and work it through that way.
That's all things though. That's dealing with your executive project managers. If you're below superintendent, that's dealing with your superintendent. That's all things. If you find a problem, you need to bring through solutions that are viable. If you're not doing your job.
Don't just show up and say, how do you want to do this? Because you're setting yourself up. You know, you may have thought out 3 weeks down the line that after this, I'm going to run plumbing, I got to run a vent, I got to do this. This is going to hit that beam, blah, 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 blah. You've, in your mind, thought of that critical path we talked about before, that you don't want to get this in, and now you've created another problem because you've just blatantly moved the wall 6 inches. Then you get up and you're landing on an I-beam, you can't do anything. Think it through and give the answer that you think makes the most sense globally. Okay? Give them reasons, give them facts, and then make sure you get an answer because you still want to hold them responsible for the solution. Okay?
When you're looking out, when you're looking at those plans, when you're going into that framing layout, when you're going into that, when you've thought through that, when you look at that process, it may take an extra 30 minutes early morning. It may take an extra 30 minutes after your kids go to sleep. But I promise it's going to help your week in the long term. Because if you're trying to do that, if you're trying to deal with that, and 10 other subs are standing next to you going, where does this plumbing go? Where does this electrical go? I got to move earth. I got to do this. I got to do that. And you're not in front of that, then you're adding that to your plate during the day. The further you are looking out, the further you are looking at what you have coming, the better off you're going to be as a leader on your job site. Okay? Let's get to our Monday morning meeting. Thank you, Joe. Let's go.